Team 73, consisting of Will Connors, Jose Diaz, Carlotta Hicks, and Maddie Ramos, is proud to present Project EARWORM. Project EARWORM is a sponsor project in collaboration with Universal Music Group. Our work analyzes musical artists through the lens of social media engagement and helps UMG plan cross-artist coordination.
Universal Music Group is the world's leading music company, capturing over 34% of the digital music market industry. As such, UMG manages the careers of icons from Bob Marley to the Rolling Stones to Drake, as platforms like TikTok and Twitter increasingly dictate what music releases break through into the mainstream. UMG aims to do a deep dive into these platforms to understand how audience participation drives the popularity of artists and track selection, allowing them to discover potential artist collaborations, which could yield brand new audiences.
For data, we used a UMG artist dataset which contained a sample of their artist and corresponding artist info, such as ID, name, genre, subgenre, and social media links. We also created a custom Twitter dataset which contained a subset of 167 artists that had less than 100,000 Twitter followers with Twitter follower data. We created this dataset by combining scraped data from the Twitter API and data from the UMG artist sample.
Before beginning our analysis, we looked into the genre and follower distribution of our sample. As you can see here, the majority of artists fall under pop, rock, and hip-hop. The follower counts are also significantly skewed to the right, with many artists having under 20,000 Twitter followers. We now move into our analysis. We defined our artist similarity metric as a percentage of follower overlap between two artists, taken with regard to the following of the smaller artist. In doing this, we can better identify collaborations between large and small artists to increase small artist visibility. With our metric, we then calculated the similarity between every pair of artists to create a similarity matrix. We added a heat map to understand how similar most artists were, and revealed that most pairs share less than 1% of their followers. With this information, we created a new dataset covering the similarity between all artists. This dataset was used to inform our results.
Using the similarity matrix, we are able to show connectivity between the artists via Fanbases using Cohort diagrams. The diagram on the left displays the strength of the similarity among artists. The diagram on the right displays the associations among artists.
Here we have a breakdown of the similarity between genres, which we got by looking at the average similarity score between artists in each genre. We see that artists are most similar to other artists within their own genre. This info can be used to inform out-of-sample collaborations.
And now for our dashboard. On our dashboard, UMG can explore the top 5 most similar artists for every artist in our sample. We also have a similar artist tree map. On the larger map, we can see the most similar artists within the whole sample. We can also select a specific artist. We use the updated tree map to see the similarity beyond their top 5 matches. On the right, we have our genre breakdown, where you can see the top most similar genres for each genre. You can toggle whether or not you want to see the same genre displayed, and you can also choose a specific genre to see the similarities between that genre and all other genres represented in the sample. This dashboard provides value to UMG by building upon their already existing artist dashboards with insights that can lead to collaborations and increased audience reach.
Our work took information from UMG and Twitter to create a new perspective on artist similarity for a pilot sample of UMG-signed artists. Packaged into a self-serve dashboard, UMG analysts planning artist collaborations can use our metric and interface to develop new insights via follower overlap analysis. This, combined with our analysis of genre, delivers unique value to UMG. Were UMG to build on this project, we see 3 immediate improvements we'd make. First, scale the number of artists in the dataset beyond our limitations and add non-UMG artists, boosting the power of the analysis. Second, incorporate features from additional data, such as Spotify song features or other social media data in UMG's data vault. Lastly, we'd use the additional data to build a predictive model of similarity in the context of music similarity and social media similarity.
In closing, Team 73 would like to thank Universal Music Group and Correlation One for the opportunity to work on this project.